Plate Tectonics by Aaron Weiss. What is plate tectonics? Plate tectonics is the theory that Earth's surface is divided into a few large thick plates that are continually moving. How is this possible, and where's the proof behind this theory? One way to prove that the Earth's crust is moving is through a process called GPS maps. A GPS map is a map that shows the movement of plates by recording the movement of receivers on the Earth and displaying the data on the map. These receivers are also known as GPS stations. The data that is displayed on the map is very simple. Arrows point in the direction in which the GPS stations are moving. To know how fast the station is, you use a key. This key gives an estimated distance over a year's length of time. For example, 15 centimeters a year. This is the key. And this is the map. GPS graphs are yet another way to prove that Earth plates are moving. How it works. GPS graphs are very similar to those of GPS maps, and instead of being displayed on the map, it is displayed on the graph. The graphs are separated into three pieces of data: latitude, longitude, and elevation. Latitude, longitude, and elevation. All these graphs have a rate to show the precise length of movement over a given year the plate has moved. For example, 6.24 centimeters a year. Here's the visual example. Here is the rate, 3.76 millimeters a year. Here's the single graph out of three. Convection currents. Convection currents are synchronized movements of magma due to the heat near the Earth's core that drives the movement of the Earth's plates near the surface. Magma that is closest to the core heats up and rises above the cooler, denser magma above it. As magma rises, it eventually hits the crust and cannot travel up anymore. So the magma travels horizontally in all directions. This friction pulls the plates above it apart, creating a mid-ocean ridge. The magma continues to pull the plates apart until the plate hits one another. As plates hit, whatever plate is older will subduct underneath the other one. This is because the older plate is colder, and therefore denser, so it sinks. Once the magma sinks back down to the core, the process is repeated. The Himalayas is one boundary I chose. The Himalayas is home to Mount Everest, the highest mountain in the world, above sea level. Plate tectonics had a major role in creating such a high mountain range. At this continental to continental plate boundary, there is no subduction because neither plate is less dense than the asthenosphere. Because there is no subduction, the plates that collided together have nowhere to go but up. This point of no subduction is called the suture zone. The Tibetan Plateau is created along this zone. Mount Everest became the tallest mountain because of the suture zone constantly pushing the mountain upward. The Andes Mountains is the second boundary I chose. The Andes Mountains are a result of oceanic continental plate boundary between the Nazca and South American plates. At this converging plate boundary, the Nazca plate subducts underneath the South American plate because it is older and denser. A volcanic mountain range occurs along this boundary, forming what is known as the Andes Mountains. A trench is created close to the shore near this boundary. The trench is the location at which the plate is subducting underneath the other. Thank you for watching.